Okay, so in this video we're going to take a look at finding the potential above a ring of charge, and we're looking at being above the center of the ring. This problem is actually a really simple one because we get to ignore angles. Remember that potential is a scalar quantity. Also take note that we're looking at a non-Gaussian distribution, so that means we're going to have to use the Coulomb's law approach, which is going to be V is equal to the integral of k dq over r. As you can see, I've already noted that the ring has a radius of capital R, and the distance from the edge of the ring to the point in question is the square root of x squared plus capital R squared. So we're going to rewrite this as V is equal to k times the integral of dq over the square root of x squared plus r squared. But you really need to take notice here that both r and x are constant. Neither one of these terms is going to be changing as we go around the ring, because we're integrating each of these individual chunks going around the ring. So as a result, this integral becomes very, very simple. So we have V is equal to k over the square root of x squared plus r squared times the integral of dq, and the integral of dq is just going to become q. So the integral of dq is equal to q, the total charge which is on the ring. And so that leaves us with a final answer of V equals k capital Q over the square root of x squared plus r squared. Now, the one thing that you should do is always check your answer for reasonableness. And so any time you have an object of finite size, then you should be able to approximate the size of the potential or the field or even the force as though the object were a point charge. And so if we take this thing in the limit as we get very, very far away, so if x is much, much greater than r, then what happens is this r squared term becomes insignificant to the denominator, and it appears as though you have the potential is equal to kq over x, which would be the same as the potential for a point charge. So our solution checks out.